Dooby doo 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 doo. Platform, GL shaders, default, Sumo. The reason why it didn't matter what the order was is because it's the order that I chose here. I'm passing forward the vertices that I choose. So I was being a bit silly with that. Not getting that, that's why I choose the order. The next thing I'm going to do is verify that this is in fact making sense. If I multiply this by 1.5, I should have the top left vertex move. It didn't. That's because this one is not the right one. Through the here. If I multiply this one by 1.5, the top left vertex should move. And it did. If I multiply this by 1.5, the same vertex should move upwards. What's wrong? Oh, stray character. It did. So what I'm doing is checking reality right now. That one we won't see. What about this one? If I multiply this by 1.5, that should be the top right one moving to the right. It is. Now, and so it carries on. Now, the first vertex in my list is vertex 0. And the second is vertex 3. See, and vertex 3 has come out blue even though it's listed second, which means that these colours are per vertex, such that if I do this, then the bottom right becomes magenta. But in a most confusing maneuver, it has also made the top right magenta. This is a clue to the problem. This is a clue because we have blue and it has appeared both top and bottom. even though in theory it should be green. Next check. If I make the vertices, you are all the vertices that are all the vertices, all the vertices you are. Right, so we've done this. Everything is red. Now, if I put everything, well, everything to 1, because there ain't no debugger, you see. So there isn't even any logs. So really, you have to use a different kind of debugging technique known as fiddle with it and see what happens. So I've got everything 1, and this I have to understand because I am setting all the colors to be the same as the color of vertex 1 that arrives at the geometry shader. And when I do that, I get blue. And that's wrong. It's got to do with the way it maps the colors. And the colors they're not per vertex, they are per index. I mean, that's the only way that would make sense, isn't it? Because 1 is 3, 3 is blue. 1 is 3, 1 is 3, 0, 1. The index of the index. The index at index 1 is 3. The color at 3 is blue. And then this is blue again. Now, if this is right, it basically means I need to write out 6 colors. And they need to be following. I thought I tried this yesterday. It would need to be like this. The first color is 0. Sorry, the first index is 0. 0 is top left, 0 is red. Second index is 3. 3 is bottom right is blue. The next one is top right, which is green. And then on this one, we'll just make white to see what happens. So if I've understood that correctly, the way it looks, it's all become white. Why? No. It's still not making sense. Okay, let's start at the beginning. Oh, no, all right, I already know that one worked. I don't need to do that again. I know that that one worked. I got red. But now I'm using index 1. Index 1 is 3. 3 is white. Gosh, I'll just get keep going in. It's because there are too many variables. It's difficult to hold it in my head. Too many indirections is quite difficult. Index 1 is index 3, which should be blue. But the problem is the third one. Okay. Right. This is blue. It's correct because the second vertex in the list is index 3, which is blue. Oh dear. Let's go set this to 2. Okay, let's try again. See, and that's where it all breaks down. Oh, well, at the moment it's because it is blue. All right. Is it like that at the beginning? Oh, it's because I had the order wrong. Right, so now it's green. So how does it work? 0 is red, 3 is blue, 1 is green, and the last one really doesn't matter. No, the last one is the colour of the other side, which I'm going to make white. Because this is going between 0, 3, 1. And the last one is 2, with position 3, colour, position 2, colour white. So 0, 1, 2, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. Right, so we end up with this situation again that we have 2 blues. Which doesn't make sense because when I used index, okay, so that's some other bug. Wow. Not 3, 1, 1 should be green. Something very odd here. Most colours don't matter. If I say 0, 1, 1, right? What do I get then? Nothing. No, that's because it's a degenerate triangle. Say 0, 1, 2. What do I get? Oh, now I managed to get green. Yeah, this actually makes sense. 0 is red, 1 is green, and 2 is white. Well, 2 should be yellow. That is correct. Not 1, 2 was correct. Not 1, 3, and it's failing to pick up the third colour. Oh no! Oh, don't tell me. Seriously, are you telling me that the colours are not going to respect? I can't get the fourth colour. I can't see the fourth colour. Unless I have to sort of do it twice. Let's try. Right, so what I have here, no, still doesn't work. I've got a bad feeling about this. If I go back to one triangle, there it is. And if I change one of these to, say, 3, becomes blue. No. It didn't become blue. makes no sense why I end up with green twice. The colour I put here, if I make this white, do I get white top and bottom? Oh, no, that was the yellow one. Start again. If I change the green to white, do I get white top and bottom? Yes, I do. Which basically means this colour is being applied to two vertices. What am I missing? What's this out of X4? Why is that not an error? I don't know. Okay, well, let's try, if I do this, the first vertex. Oh my God. This just doesn't make sense at all. Well, here, this has made the whole thing red, which is great. And then if I do this, it makes it green. And if I make it, oops, I should make it all yellow. Now it's blue. Yeah, why? Well, because it was 3. If I do this now, I get yellow. Okay, that's fine. And what happens if I go and put in number 3? We get red. Because 3 is the third colour. If I do this, then we should get blue. Yeah, okay. So what I've got then is triangle. I can then specify the third vertex. and the third vertex is blue. So in theory, that's working. So I've got access to all the colours. And the final two are going to be, I'm going to do 0, 1, 2 again. So then if I go to number 4, this should become red. No, yeah, it's green. So why is that? No, no, green. I said 1. That's green. That's fine. And if I put this in 5, then it's yellow. So it looks like the geometry shader is getting the correct information. Yeah, the geometry shader is getting the colours as I put them in here. So what I do for this is specify 0, 1, 2, 3. And these two don't matter. And all is good. Then I start the second one. And I'm going to do the same again. Let's do that as a test. Now I'm reading once again. But this would be for the second. Now I can actually turn off the first triangle by doing this, making the first triangle degenerate, and then it doesn't draw. So now I know I'm drawing the second. That's how I'm going to try it. So if I do that, then I should get no triangle at all. So what I've got then, I'm checking if I can continue with the second triangle. The second triangle being the same as the first, so it's kind of like a scientific experiment here. Does the second triangle behave the same? This should be green. This should be yellow. And this should be blue. Yeah, so at this point, everything there seems to be working correctly. Now what I'm going to do is I'm using 4 vertices at the moment. I'm going to keep these 4 vertices, but apply an offset of +1. So the second triangle should be repositioned, and it isn't. That's because I'm using the indices of the first triangle. The indices of the second triangle start from point 4, 5, 6, and 7. This should shift it. Yeah, and it's got smaller because I added to the z-axis, so it's actually moved it backwards away from the camera, which is why it's smaller. So that all makes sense. And this is green, although it's a bit of a weird shade of green. And the reason is because I haven't actually specified the true colours of these, which there are another 4 vertices, and I have to give the colour of these vertices. This should be the proper green. Ah, it's come out blue. So the first vertex, the first triangle came out okay, but the second triangle did not. Now, let's see. If I take out the first triangle, does it now work? No. 0, 1, 2, 3, 4. It should be red. So it does depend on what colouring I'm. Yeah, I'm going to draw it. It should be red now. That's sorry. Yes, that's red. That's fine. This should be green. So this should be blue. Yellow. I mean, that's blue. Sorry. 2 is yellow. And 1 is green. And 0 is red. So it seems to be working fine. So at this point, this is making sense. For the second triangle. Right, yeah. So this is all great. The second triangle is correct. Yeah. Let's do both triangles. Right, so we have both of them are red. And that's because in here I am picking out the red colour for everything. Now yellow, and finally blue. Yeah, so all of that works. Now we'll go back to what this should be. 0, 1, 2, 3. Oh, it's the UVs. I think I understand what's wrong. Because this algorithm, so I verified that the data seems good. The problem is the interpolation algorithm, which depends on the UVs. So if the UVs get swapped, it could swap the colours and end up making green on the side. Okay, got it. There's nothing wrong with this, but that's good. Now I've confirmed that that all seems to be correct. When I try and do this now, the first triangle is correct. The second one should be the same as the first, but isn't, because the UVs are not correct. Oh, that was what I was missing. I need to redo the UVs. Oh, a bit heck. So basically last night when I was going, why is this not working? Why is this not working? The reason it wasn't working was because I hadn't set the UVs up correctly for this arrangement. They're still set for the old arrangement. Right. That means I think I've almost done it. Yes. My mission to make a perfectly Gouraud shaded cube out of quads that actually behave like quads and render like Gouraud shaded quads. That is two-way interpolation of the colours. I've been at this for a week. But it's taken me all the way around the whole of the OpenGL pipeline. So it's been actually an excellent exercise. So if Yeah, what I'm going to have to look at here is the UVs. Yes, so the first UV is 0. The second UV is it right. Yeah, this is basically saying the UV for vertex 0 is 0, 0. That's correct. The UVs for vertex 1 is 1, 0. That's moving it on the X, the Y, not change. The UV for the next one is 0, 1, because it's the yellow one. And then finally, we have this blue corner. In the blue corner. Right. Now, we will check this. What I should get is one triangle, and I've got an error. UV's redefinition, really? I thought I just moved the other one out. Oh. What's wrong now? Unexpected endeth. Really? Okay. Now, this is good, but I'm going to do some testing of the UV theory here. If I go and put this here and this here, what I should get now is the green and the red should swap. And in fact, they did, which is all looking good. And if I move this here and this here, I should end up with blue instead of yellow. Yeah, that's all working well. Good. Now go back to the normal. That's great. Now construct the second triangle and its UVs. So the second triangle is going to be between point 2 to point 1 to point 3, or bottom left to top right to bottom right, with the adjacent vertex for the the adjoining triangle is 0, and then those two don't matter at the end, just leave them at 0. So that looks right, but what does it do to the UVs? 0 on the X, 1 on the Y, and I'm doing this in third, and you know what, I should probably do it like this, because then I've got the UVs per triangle. So that's that one, right? So the second point is 1, which is at the top, which is 1, 0. Then the third one is 1, 1, which is bottom right, and something's missing. What's the fourth one? Oh, the fourth one is 0, 0, which is the red one. Okay, so fingers crossed here. Oh, that's so close. That isn't quite right. I got the green was right. So what did I do wrong? Yeah, you see, it's tricky because they have to think about the order in which they are done. So the first one is the yellow corner. But yeah, it has to do with how it's drawn. Wow. So maybe I can make this a bit easier by changing the order of these. To keep no, I just have to fix it. Okay, there is a blend between blue and yellow on the bottom, and the problem there is that I have blue, which means this is the wrong way round, and so this should be 1. So let's just try this. No, that did not work. Not 1, 2, that did nothing. Let's just zero out the whole of the UVs and see what happens. Oh no. It's like the UVs don't matter. Maybe they don't. Maybe I'm not even using the UVs. No, okay, the UVs are doing something. And I tested that anyway. 1, 2, 3. 4. What do I need? I don't need, no. The UVs are like colours. They belong down here. I have 4 vertices. I need to have 4 UVs. Is that right? Yeah. Then maybe it's the order in which I draw them. Naught. Oh, shit. It's got to do with the fact that when it constructs it, it's like a strip. When it adds a vertex, it uses the previous 2, but this has the effect of flipping the vertex each time. And in fact, the hardware deals with this by flipping the rasterization order, the clockwise to anti-clockwise. It has to cope with it, because otherwise, you see, when you build a triangle like this and then do another one like this, well, this one went that way and this one's going that way. So I think that the problem is that the sense of these are getting reversed each time, which is kind of a rather tricky. If that is the case, it means that the second one must go the other way. So if I say 0, 0, 1, 2, then I have to say 2, 3, 1. I have to swap these two. That's a theory. I don't know. It's a shot in the dark. Come on. Oh, it's changed it around. 2, 3, 1. No. I'm just going to end up, aren't I? Just 3, 1, 2. Oh, dear me. There's a very specific order I need to put these in. Well, there's only 6 ways it can go. 1, 2, 3. See, but each time. No. Oh, this is so close. 1, 2. I haven't got faith that this will work. 2, 1, 3. 2, 3, 1. 3, 2, 1. Three, 1, 2. 1, 3, 2. Right, let's just make sure that these are not being accessed. It's all in here. We start with vertex 2. Let's just take it a step at a time. I'll start with vertex 2. It should be green. We should end up... No, it's red. What? Blue. Why? Why? 0, 1, 2 is... because I'm being stupid, it's 1. Vertex 1, top right, is 3. 1, 3, 2. Still blue. Okay. 1, 2, 3. It's to do with the UVs. There's a... No, that's wrong as well. The first vertex is top right, which is already known to be green, but we see it as yellow because the UVs are incorrect. It's to do with the UV mapping. And how do I solve this? Yeah, what am I going on about? I'm using separate triangles. I can draw, they're not attached. There's no, that whole thing with it being a strip was total nonsense. We draw one triangle, we draw another triangle. Each triangle requires 6 verts. I successfully draw the first triangle with the 6 verts, but each vert is specified with an index. Each one also has UVs, but the UVs don't map properly. Why? Because I'm sharing. I'm sharing the vertex between the two triangles. I can't do that because I need to have a different UV value for both. There's nothing I can do about that. So this actually needs to be done in triangles. That's the first triangle for which we have the UVs, these UVs as marked like that. And then the index becomes 0, 1, 2, 3. That's great because it's index 0, index 1, index 2, and index 3. Yes, so I need actually 4. Got it. Right. And what needs to happen then is I need to do the second one. The second one is the same again. So I have to replicate the same, I have to duplicate the same vertices. So that then I can specify separate UVs. In here, this becomes 4, 5, 6, and 7. So we got this is 0, 1, 2, 3, 4, 5, 6, 7. So yeah, this is duplicated their position, but they're not the same vertex because I need a different UV to map them correctly. This way I can keep the first set correct, the same, and now I need to change the mapping of the second, where the sense of the UVs need to be adjusted. And what I'm going to try doing is swapping, because I could try and do it mentally, but it's a real brain ache. Let's just try swapping this first of all. What do we get? And right, that we only got one Y. I lost the second one, Y. We've got colours. Well, these are additional vertices. I need to have 8 vertices now. I'm going to just double the colours of the vertices as well. Try again. No, it's still not appearing. Why not? It's index 4, 5, 6, and 7. That should work. 7 UVs. That needs to be 1, 1. There should be 4 pairs here. So okay, it's just that. Is this going to fix that? Don't think so. No. Yeah, because I'm drawing on top of the 5, 6, 7, 4. Because that, yeah, it's duplicating. I was drawing it on top of the first. Okay. Now the green one is correct, but the red one right, so we look at the UVs. Right, the fourth colour, which is here, that one, is it? Wait a minute, it really gets difficult because that depends on the order that we have them here. So 4, that's 0, 0, but not with the new UV mapping. It needs to be 1, 1 because it's kind of reversed, I think. Oh my God. Right, the red has gone away. So that's good, right? Because the red is... Hey, Gavin. How you doing? New face, welcome. The topic is the same as it's been for the last week, which is I've been on a mission to efficiently create a quad. It sounds very silly, but there's more to it than... Because a quad is made of two triangles, triangles. Anyway, it's made of two of them, yes. But what I want to do is a 4-color interpolation between the corners, which sounds trivial, but it isn't, because the problem is that the hardware that renders the triangles can only see 3 vertices at a time. And it needs to see 4. You need to see the adjacent vertex, right? Because you've got this here, it'll blend between these 3, but I actually have to blend to this one. And so I've been going through various solutions. The current one uses a geometry shader, fragment shader, a vertex shader, and some tricks to replace the normal interpolation of the colors with a UV-based interpolation that uses using adjacency to get the color of the... It's something I didn't expect to be so hard, but it turned out to be actually quite a journey. But since I'm learning OpenGL, the latest incarnation of OpenGL, it's proved to be a very good exercise. So that's it. And I've nearly finished. I think I have everything other than picking the right UV values. So 1, 1, right, so the next... So first was 0, so 1, 1. That one bottom right is wrong. That bottom right one should be blue. I think what I'm going to try to do is swap. Try to swap these two and see what we get. No, that didn't work. That's because I've got two the same. So 0, 0 gives me green. Think about it. 0, 0 gives me green. I'll do this in my head. For the second triangle, 0, 0 is green. This much I know, right? And green, okay. So the top one is right. Oh. All right, well, if 0 is 0, 0 green, then which one should be 0, 0? 0, 1. Oh, because of the way the algorithm, I have a way of working this out. Because of the way the algorithm works, if I make the UVs all 0, 0, 0, I should end up with the same color for the lower of the two triangles. This is green, great. So then I can just, aha, I can work it out. So we do this, and then 1, 0, UV of 1, 0 is which color? You see? And 1, 0 is yellow. And 0, 1, oh, so close, 0, 1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So which color is this going to be? Blue. I might see a pattern because I need to understand how they change. I'm going, well, that means that 1, 1 must be red. So the colours normally are, the order of the colours were red, green, yellow, blue. But in this case, it's red, green, yellow, blue. This time it is green, yellow, blue, red. But they are going in the same order. They've just been shifted around. So the rule is you start with whichever one is the first vertex. You pick its colour and then you go through in the sequence. Green, yellow, blue, red. I think I have an algorithm then that will work for this. But let's just put this in by hand first of all. So we know that the first oh dear, it's such a brain ache. Okay. All right, 0 would it be like this? Oh no. Okay, but I can look and say which is wrong. Green is in the wrong place. Green's life force is running out. We need to get green to where the blue is, but I can see where the blue is, so I can just swap them. I need to swap green and blue, where green is 0, 0, and blue is 0, 1. So I take 0, 1 and I make it 0, 0, and I take 0, 0 and I make it 0, 1. Come on, that's got to work. Oh, this is so close. Blue is correct. The only one that's wrong is the red. The red one is 1, 1, and 1, 1 should be yellow, which is, so I swap them. Swap this with 1, 0. Oh. That makes me very sad. Looking at this carefully, I see something. I see that there is blending to the blue corner from the red. You see this blue here? It should blend from red to blue, and you can see it's getting darker here. So what's gone wrong is this triangle is blending between yellow and between blue and green, but for some reason it is not blending between green and red. Now red is 1, 1 for this triangle, UV 1, 1. 5, 6, 7, 4. Oh, that's so crazy, because the first triangle is definitely blending correctly. The second one is not. It's like it's not picking up the adjacency. And if it worked for the first triangle, it should work for the second triangle. Let's check the UVs. 1, 1, 0, 0, 1, 0, 0, 1. There should be all the combinations there are. We have 8 vertices, 0, 1, 2, 3, 4, 5, 6, 7. 8 colors. So the rule has to be, it's maybe to do with the order in which I'm drawing the triangle. The first one I did was 2, 3, 4. The order I'm doing them in now is this is 0, 1, 2, 3, 4, 5, 6, 7, and I'm going to 5, 4, 5, 6, 7. I'm rendering 5. So I was going clockwise. This one is going 5, 6, 7. Okay, well, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2. Here's the third, fourth, 0, 1, 2, 3. Maybe I need to do it in reverse. 3, which is actually 7 now. 6, 5, 4, 3. Okay, I can see some blending to the red because there's a little bit of sort of magenta going on here. So I think it was to do with I was not using the right order. So what I'm doing now is I'm rendering this one, this to this to this to this, and I'm starting from here and rendering this one, this to this to this to this. So it's the mirror image of the first. Now the UVs are all upset, so I have to start again. Start again with the UVs. So 0, 0 is blue. That actually makes sense because this is now 0, 0 because this was the first one. 1, 0. And this is like a kind of programming Rubik's Cube. The second one is yellow. 1, 0 is yellow. Then we want to go on the next one, which is like so. It's green, which means 1, 1 is red. So let's try again. The first is the bottom right, which must be blue, which is 0, 0. The second one, so I'm going to here, it should be yellow. Yellow is 1, 0. Next one should be green. Green is 0, 1. And finally, this should be red, which is 1, 1. And it's come out the same UVs. That's interesting. Okay, never mind. I know I need to swap red with blue, so let's just swap. 0, 0 needs to be swapped with 1, 1. Oh dear, that theory didn't work. What have we got now? I've got that's it. I'm almost there. I can feel it. It's like the last twist of this. I need to change the yellow and the green. God, this is such a long road. I know I've changed it. I've got a good feeling about this one. Yes! This is now a properly interpolated quad. Again, I've had it before, but this one is using the geometry shader. So the definition of this is very simple. It's this. These are the vertices, which I've specified 8, even though there's only 4, because I have to specify them twice. Because I need different UVs for the second triangle in order to get them to sort of hook up properly. So this is wonderful, because as you can see, we've now got from something that was actually quite horrific. This was the setting up the colors for the cube before, where each one of these was one of those. It's being handled by the geometry shader now. So in fact, here are my indices, here are my colors. I have 12 indices because each triangle requires 6 verts, because I need adjacency information. So 2 of these aren't really used in this example, so they're just 0 in this process. I only really want 1 piece of adjacency information, which is the 4th vertex that we've got to blend the triangle to. And we've got colors. So there's the colors of the vertices. 4 vertices, the colors aren't changed. So in fact, this is duplicated. It gives me 8 vertices. Here are the UVs for the 8 vertices, which are different between the first and the second triangle to make it mesh up. And here are the verts. So I can expand this now to a cube. I have had the cube before, but not using the geometry shader. This is a big deal. It's a big deal for me, because I wanted a actual usable way, and the reality is that what we had before wasn't actually usable. I don't know what I'm supposed to do here. I replicated. I seem to be missing one set. Oh, whatever. Just go away. Start again. So that's all good. I'm going to turn the spinning back on. So there we are. It's probably a little close to the camera, which is why it's flicking. I need to pull the camera back, I hope. Camera position -2. Yeah, it was. It was hitting the near clipping plane. There, I'm going to raise the camera height up a bit as well. So now I need to construct my cube, which I have 1, face of the cube as an actual quad. It is a real quad, not two triangles. Well, it's drawn as two triangles because OpenGL will draw it as two triangles, but it is actually a quad in that it has 4 different vertex colors and blends between them. So quite excited about this. We're going to go and try to add another face. So I need to add more vertices here. I'm going to start with the back. These were the front. This was the front face. Right. And so by copying all the vertices and moving them back, we're going to have a second face. These 4, 5, 6, 7. This is going to be 8, 9, 10, 11, 12, 13, 14, 15. We have 15. We have 8 more vertices. The colors of the vertices are probably going to stay the same because, well, no, well, they need to change actually because they have to match up with the, yeah, they have to match up because the corners all have to agree what the colors are. Oh, why do I keep doing that? It's because I've been using Visual Studio all day. Right, there we go. So what we're looking at here is the back face. I can tell you that they have to be opposite colours to whatever they were on the front face. So the front was red. You can see where it goes. Oh, the order in which they render. But yeah, let's get the colours right first. So the one right at the back on the top needs to be the opposite of the one bottom at the front on the right, which is blue. So this one should be blue. The second one is normally green, but we move it to the back. It needs to be opposite of yellow, which means it's yellow. There we go. So the opposite corner is yellow. This one, at the front is yellow. At the back must be green. And this one is blue, but at the back must be red. And so, like that, we should have the correct colour for the back side. And then this is copied twice. Basically, it takes six verts. No, 8 verts. 4 verts. Yeah, right. So right. So yeah, this was the first face. The second face is then going to start using the colours, actually the vertices from 8 onwards. Now, in fact, we have to start from. I'm doing it in my head now. We'll start from that. Was no. Ding, one at the back, but we have to actually start from this one, which is 9, and go back to 8, then down to this one, which is 11, and then the opposite side is 10. Just check that. 10, 8, 9, 10. Yeah. And then what I did for the second one is by doing that, I'm going 9, 8. I'm going anti-clockwise because viewed from the side it would be clockwise. I have to go in the same sense, but starting from the opposite side, which is 10, 11, 9, and I guess then it must be 8. And the UVs, the terrible UVs, are probably, I think, going to be the same. There's going to be the same pattern, I hope. I don't know, let's see how this works. Okay, something wrong with my mental juggling there. Well, both of them start with 8, 9, 10, 11, which is correct. Oh, right. Okay. I need to. Right. So let's just make the 0, 0, 0, 0 for the minute, and we'll redo it. So I'll just have one triangle on the back face. I'll verify that this one is correct, and it's not. Oh, but the UVs. See, I started off with 0, 1, 2, 3, 8, 9, 10, 11. So I said the first one would be blue, but it's not. Yeah, so I had these the wrong way round. So 8, 9, 9 should be blue. So I'll just swap these. Let's try this again. What I should have then is, yeah, I want to see the blues on opposite side, which is right. I ended up with white, which is wrong. That should be opposite. Yeah, I think this works. I'm going to trust that the UVs are okay with that pattern if I stick to the other rules. So blue is opposite corner of the blue. The yellow is the opposite corner of the yellow, but the green is not. So I need to swap the green with the red. So now the reds are opposite corners of the cube, blue's opposite corner of the cubes, yellow's opposite corner of the cubes, green opposite. You can't see the other green because I need to do the other triangle. Okay. Now the rule is I had for the first one is 0, 1, 2, 3. And then I do it backwards. So 7, 6, 5, 4. So if I know that, then I can do this as 10, 11, 8, 9. And if I've got this thing, okay. Not quite right. So let's see. 7, 6, 5, 4. Whether it was 0, 8, 9, 11, 10. No, 9. Look at it carefully. 9, 8, 11, 10. 10, 11, 8, 9. No, that's right. No. You've got to add. Another way of looking at it is add 7. No, not add 7. Add 7, add 5, add 3, add 1. Add 7. Add 5. Add 3. Well, add 3. That's better. Can't do maths. Add 1. So this goes from Add 7, add 5, add 3, add 1. Because it depends on the flipping order. Subtract. What's the pattern here? If I subtract this away from 7, so 7 minus 0 is 7. 7 minus 1 is 6. 7 minus 2 is 5. 7 minus 3 is 4. It's where 7 is the last one, of which is 15. 15 minus 9 is 6. 15 minus 8 is 7. No. Okay, start again. Take, yeah, it would be 15. I can't do the mental arithmetic here again. We do, yeah, these add up to 7 because they're just basically a reflection of the whatever. So if we say, let's start with the lowest of them, which is 8. This is 15. 9 is 14. 10 is 13. And 11 becomes 12. It's just that. Okay, try that. Okay, well, blue opposite, red opposite. It's not quite working out right, is it? The green is on the lower triangle. The green is should be red. That did not work successfully. Topic is hi Mike, how's it going? I got the adjacency to work. Do you see that? Do you see the first one here? The one that was work. That's it. That is using adjacency. I got it to work, but it's like a Rubik's cube. It's like now I'm trying to do it again with the back face, but with a pattern, and it's not going too well at the moment. I need to picture, I've got to write this down, I can't do this in my head anymore. Zero, 1, 2, 3, 4, 5, 6. Well, that actually isn't, because I need to start this off at 8. Because they're duplicated. 8, 9, 10, 11. Looking at this from the back, 9, 8, 11, 10. The first one should be 9, 8, 11 with 10. And the second one should be 10, 11, 8, but I need to add 4 onto those. So that's 14, 15, 12, 13. That is theoretically correct. 9, 8, 11, 10. Oh! I was editing the colours. These colours have to be duplicated. There. Yes! I am levelling up. Okay, I almost succeeded in getting there without you just using my head. It's good mental exercise. How's that? That's it. I just need to do this. I am a third of the way there. Right. Now it turns out that let's do the next one. The next one. Oh. Right, so that's back. I'm going to try to do the right hand side now. For the right hand side, these will all be positive, but I will be going between height and Z. So what we'll do is swap these. That's it, and then make these all positive. And then check. And this is going to be vertex 16, 17, 18, and 19, and then you can go from front, top. That one is front, top, right. This one is front, top, left. This one is front, bottom, left, and then we have bottom, no, that is bottom right, and this is also bottom right, so I'm just getting confused there. In fact, these are all right. All right. So we have front, top, back, top. You've got front, top, right, back, top, right. Then we have front, bottom, right, and finally back, bottom, right. And then these need to be duplicated. So I can set correct UVs, 22, 23. So this way, I think I have the right verts in there. Next, let's see if we can compose the correct sequence of vertices. This is now looking at it from the right hand side. And so what I have to do is map the numbering of the vertices so it's drawn in the same way as the one at the front was. So let's just check the order I put these in. First one should be front, top, right. That's correct. Second one should be back, top, right. That's correct. Third one should be front, bottom, right. which is correct, and then back, bottom, right. So yes, so they are in the right order, so that's good. So that actually means that I merely need to copy this and add this one, because no, not that one, because that one was reversed because it was the back one, but this one is not. This one is plus 16 because the first one of these is 16. So I just need to add 16 to it. So it becomes 16, 17, 18, 19. And then this is the same as that one plus 16. So 16 plus 17, 23. Comes both 23. Sorry, I'm just getting confused again. I need to add 16 to this, so that becomes 23. Adding 16 to this is 22. Adding 16 to this is 21. 16 to this is 20. So I should have another face, I hope. I do. So just need to set the UVs. Well, the UV should just work if I keep the same pattern. I hope. UVs, please. Ooh, no. Well, the colours need to be. Let's see if I can fix the colours next. The colours can't be the same each time. So the colour of the first vertex is green. The colour of the second one is yellow. The colour of the third vertex is blue. And the fourth vertex is red. And this needs to be duplicated. Come on, let's see if we can get that. Right, well, not quite. There seems to have been a white introduced, which is a bit troubling. That white should be, in fact, yellow. Try again. Right, let's look at this. I seem to still have a white in there. Ah, that's the... That was the second one, used to be the same. Right, see, we're still... Right, it seems to be a yellow. Yeah, it's not quite... It's really not matching up at all. So I need to check. Let's start with the vertices, and I'm going to get some paper because it's too difficult to work out in my head and get it right in a reasonable length of time. This side piece, this side one, full vertices, their number are 16. Actually, I just realised something. These vertices and the drawing of these triangles are completely independent, so I could use a numbering scheme that makes a little more sense, that it's always numbered looking face on, and I didn't do that for the back one. Now I want to, because then the pattern is going to be a bit easier to manage. So if I did that, then how would that work? See, this then would become Yeah, I'm going to cut this back because I need a better way. So I'm taking this out. Take this last one out. The UVs keep, and let's comment out these, and then check I'm back to where I was with this. What I'm going to do is recreate this, refactor a little, so that I've got the numbering in a way that makes more sense. What I can also do is add plus. Each one of these requires a shift of 8, so it's 8 times 0. Or hash define Q as Q0 as 8 times 0. Actually, let's put the number in there. So I'll say A, and then it'd be A times 8 times 0. Then I could just say Q0, Q A comma B, maybe B times A times 8 A plus 8 times B. Q 0 0 Q 0 1 Q 0 2 Q 0 3 Q 0 0 Q 0 0. So there we are with 6 of these. P. Now P is going to be shut up. You're a game dev as well. You do like B, right? So what we do is see if this formula works. So if I do 7 minus B, see, that should be fine. On the second one, I repeat the same pattern as before now, but what it does is it will create the other face for me. Never underestimate the power of Q or P, all your P's and Q's. Oh dear, I just used this. How did I How do you get the second? I don't know how I did the second selection. Oh, I keep forgetting how to get. How do you get the second selection? I need to. All right. No. Okay, that'll do. Comment region. Thank you. I hope. Okay, that worked, right? So I've got my whole thing there. Now, the whole point about this is that I should be able to get this algorithm, which I could do with the for loop and all that later, but for now, it's just do it this way. So what I can do here is just set this to, just realize something. This then becomes 16. No. 1. 1. 1. This is the face 1. The first one is face 0. So with that, I can get my second face in, I hope. It's probably going to be a bit screwed up. Oh, not even there. Why not? Ooh. Oh dear. So this would be 0, 1, 2, 3 becomes oh no, it was right in the first place. Why would I change that to 16? I was confusing myself. Yay! That actually worked. The colours are wrong because they're not opposite sides anymore. But then we can fix that easily enough. So which one was the... Yeah. I need to swap the yellow and the blue. The yellow and the blue. Hang on, that's not... I've swapped the yellow and the blue. I need to do that twice. Swap the yellow and the blue. We got there. Blue opposite blue. Oh. I've got to swap green and red now as well. I'm looking for them, for the colours to be opposite each other. And duplicate that too. Yeah. Oh! I thought I just swapped red and green. They are not swapped. Did I just mess up? I must have just had a brain whatever. Look, yeah, that's correct. Blue opposite blue, red opposite red, green. Yeah, okay. the UVs repeat. This pattern repeats. The only thing we have to then do is fix the colours, I hope. Let's just check the order of the vertices. On the back, it was front, top, left, 4. Front, top, right, 5. 6, 7. Yes, that's correct. Excellent. So we're going to go with the next side. Should go a bit faster now. Let me uncomment these. And yeah, 16, 17, 18, and 19. We need to make sure that we are, this is set this way. We need to make sure we are front, top, right, back, top, right, front, bottom, right, back, bottom, right. That is correct. And that is repeated twice. That's correct. And we can get, and so, well, with that numbering scheme sorted out, it should be enough to copy this. And then just put 2s in here. On here we go. Oh, yeah, we go. Ching, ching, replaced with ching, ching. Like so. So, yeah, maybe we'd like to try that again. Sorry, I just seem to be confused there. Where did 2 come from? Okay, I don't know what happened there. I'm getting tired. I'm actually seem to be making mistakes. 1, 2. I'm not used to doing that. Like not those kind of mistakes where I've actually concentration's actually lapsing. But then I did do a full day's work already. But this is fun. Right, what I want to do is, I've got that, and then I want to set the colours up, which I didn't set the colours up yet. So let's just copy the existing colours and I can swap them around. Yeah, let's try. We also need to do UVs, but the UVs I should be able to copy. I don't know, they were missing. So UVs. Oh, that's looking good. That's looking so good. We need to swap blue and green. Oh yeah. Oh yeah, isn't that way? It's so beautiful. It's so beautiful. Oh yeah. Okay. Next. Next, we're going to go and do the same on the other side. So we go like that, and the order needs to, well, first, yeah, so first of all I can just go, and that's the right side, but they may not be the correct order. First one needs to be back, 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 top, right, back, top, right. We need to take that one, put that there, back, top, right, which then goes to front, top, right, which is correct. Then back, bottom, right, to front, bottom, right. This needs to be duplicated. And the numbering scheme goes then to 24, 25, 26, 27, 28, 29, 30, 31. Okay, 31. It's good. We need just more UVs of the same up here. Do 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 do. And let's copy some more colours and get ready to swap them. I should have another side. Right, so the one there is one that's wrong. You can see there, I need to swap and catch it as it goes past, you see. It's like that. Yeah, swap yellow with red. Swap yellow with red. Uh-huh. Uh-huh. Right, so ooh. Yellow and red, now correct. But we also need to swap green and blue. Right, so we go like blue, green. Where's the green? And we do it. Go. Oh, and I forgot. Need to do it twice. That's it. Okay. And oh, there's still a glitch, Rooney. Oh, because when I swap one and it swapped, and now I need to swap green and swap green and blue again. I thought I just did that. I thought I just swapped green and blue. Am I hallucinating or something? I thought I just did that one. Try again. Oh, doesn't matter. It's working. That's really nice and clean and good. That's great. I just need two more. I'm 2/3 of the way there. 2/3. Let's do one more. Tick, 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 tick. Down here. Yeah. Boom. Down here. So this is more UVs. Yeah, and we also well, we need to do the face. Which one's this? It's going to be the top one. So looking down on the top, how are we going to get this one done? Well, the first thing is that for the top one, all of these are positive. And then we need to begin with the back. The back left. That's left. That's back. That's correct. That's back, top, left. The next one is let's duplicate this one. The next one is going to be the same as the top one, but right. So it becomes like this, and this is back, top, right. Then we actually need to do the same again, but at the front. This becomes front. (32, 33, 34, 35. back, right, left, right, top, back, back, front, front, all on the top. That all looks good. We need to do a second set of these, and that's now 36, 37, 38, 39, and that's absolutely great. I've got those. They're numbered correctly, and I think I should now have it. This is 1, 2, 3, 4. Yeah, that's right. Go. The top. Top is looking good, but we need to do some swapping. I need to swap the green. I need to swap green with yellow, and then I need to swap yellow with red. But let's start with green with yellow. Like so. We need to swap. Green is in the right place. I need to swap red with yellow now. Red with yellow. And then we should be good. Oh, double it. Let's just. How's that? Oh, there's still a problem. I now need to swap red with yellow. I could have sworn I just swapped red with yellow. Oh, whatever. Maybe I thought I swapped red with yellow. Maybe I don't know anymore. Right, so red with, yeah. Don't question it, just do it. And actually that was not red with yellow. So maybe that's the problem. I thought I did it. I did the wrong thing. Red with yellow. That's swap red with yellow. Come on. Ooh. Yes. Thank you very much. That's very good. Let's now move the camera so that it's below the cube so I can see the bottom side of the cube. Yeah. Time to fill that in. The final face. Dink, 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 dink. And colors. Dink. And UVs. Dink. And because the UVs, this is funny, because the UV is the same every time, I might even be able to not need to put them in. That's something to think about. It's a little tricky, but anyway, that's optimization. I'll leave that till later. Yeah, so all of that's fine. And now what I need to do is this bit. And this is where we substitute the word top with the word bottom. And we put and the only thing is that now the order will be wrong because I need to start underneath, front, left, bottom. This one needs to be first. Right, this one is right. Next one, front, bottom, right. Next one, back, bottom, left. Back, bottom, right. Yes. Okay. 39, 40, 41, 42, 43. Yes, I'll take it. Let's try. Duplicate. Didn't I already? No, you didn't. Right. 44, 45, 46, and 47. Yeah, it's looking good. I need to swap. Let's start swapping red with green. There we go, red with green. Okay, that's fine. Now we need to swap blue with yellow. It is done. Finally, we have a good optimal solution. So as you see here, what I've got are colours for 1, 2, 3, 4, 5, 6, 7, 8 vertices. Each side has to have 8 vertices specified. That's interesting. That was, why did I need to have all of those duplicated exactly? What was the reason for that again? Oh, right, because the first 4 are with one set of UVs and the second 4 are with another set of UVs. The UV is actually being inverted, as you can see from this to this. So I have to reverse the UV. If I could figure out a way of reversing the UVs in a different way, and there is a way, actual fact, I can probably use the about hack. I have some spare information here. I can get information into the geometry shader through these things that I'm not using. So I can actually pass integers in. So I could actually set a 0 or 1 depending on whether I want the geometry shader to invert the UVs or not. So, and then I wouldn't need to even put the UVs in. So what it would then be is that the geometry shader does the UVs, and what is actually generated, what I specify is just the colours of the vertices. So I think there's more optimization I can do, but anyway, that's the reason for the duplication. And it would mean that I wouldn't even need to duplicate. But anyway, you know, I want to enjoy the fact I got to this. So I've got just, this is the mesh, these are the UVs, these are the colors, these are the indices, and I get myself a cube that is properly interpolated, the different colors, and I'm very happy with that. If I could prove, yeah, I want to change the colors now. It's still a little tricky because I have to sort of change the colors in in the mesh. What I'm going to do C1 is 1, 0, 0, 1. Yeah, but I can do more optimization. C3. Oh, what happened there? That's kind of weird. Yeah, there's a special thing that a facility that Windows provides called Scramble Your Desktop. Yes, in case you weren't having enough fun trying to use a computer, it will now scramble your desktop if you happen to press the wrong key. Very nice. Good job. So I can just say now C1, comma, C2, comma, or even just put it in as like this, C1, C2, C3, C4, and then I have to say it again. C1, C2, C3, C4. Let's just see if that still works. Yeah. Second color. Set. C3, C2, C1, C0. Oh. C0 undeclared. Yes. 0, 1, 2, 3, 3, 2, 1, 0, 0, 1, 2, 3, 3, 3, 2, 1, 1. Go. Okay, that's fine. C0, 1, C2, C3, C0. Make it easier to see what's going on. Yeah, this use of defines, they're kind of handy. C3, C0, C1, C2. C3, C2, C0, C1. And finally, C2, C3, C1, C0. Excellent. Meaning now I can change the colors to be anything I like. Black, magenta, white, cyan. Cool. Different shades of red. I find that very pleasing. And one of the things I could even do with this is feed the 4 colours into the geometry shader and have the geometry shader create the cube. Actually, that would be a pretty smart move. Totally could do that. You pass in to the geometry shader a point, and it takes the point, and then it generates the geometry of the cube according to the parameters that you pass in. So, but totally procedural geometry. Yeah, I love it. This is fantastic because yeah, do so many experiments with things like that. I mean, you know, the amount of creativity you can get out of it when you stop thinking in terms of, you know, I mean, at the moment as well, I've got like each of the 6 are, I've only got 4 colours, but I could actually put it up to 8 colours. Just, is that possible? I'd do 8 colours. So I could have every corner of this cube a different colour. Each corner of the cube a different colour. Yeah, I don't see why not. Right, we can use the other colours in there, so we can have cyan, magenta, cyan, white, and black. So I'm going to try and make each of these C0, C1, C2, C3. It's the face, the 3 colours of the face. Well, I can just try. I can do that, and then on the next one, well, I need to take the opposite side. Let's try that. I've got a black. Yeah. So one of these blue ones, which is C3, just to get the right pattern. It's not the right pattern. But let's start there. So that's C3, C7. Nope. C7. Nope. Must be that one then. No. Where was this one? Yeah. And one more at the bottom. There's one underneath, which I know was this one. So I think what I've got then is C7 should be, yep, I have a black corner. C0 was the red. Right, let's try and find somewhere to put C6 then. here. We have a white. There are two other yellows I need to replace with C6. No, that wasn't it. C3, where's the others? Did I try them all? No, I'm not hitting either of those. Yellow. I can see two yellows there. I don't. They should be where it says C3. Maybe it should be this way then. No. Oh, because I was thinking of C3 when I should be thinking of C2. Yeah, for some reason I was doing C2, not C3. No. Yeah, that was correct, and then there must be another C. No. No. Right, so I've got a black and white. Do C5, which will be changing C1. C5 is cyan. Yeah, got a cyan. No. That was one of them. Be this one then. So I should give me a cyan corner, which is great. And then the last one is C4, which replaces C0. And that is magenta. Yep. No. Nope. It's actually less mental effort to do it this way than working it out which ones it should be, and then I'd have to test it anyway. Yeah, that's fine. There's one more to do. And then I have 8. Got it. So now every corner of this cube can be its own color. And let's take this one to here, a few from above. Very colourful. Perfectly interpolated, multicoloured cube. Superb. It's interesting looking at the distribution of colours that you get from this, because white subjectively is bigger than black. Isn't that interesting? So I have to make that work. Hey Mike, you're still there. I thought you'd gone. It's all so quiet. Thank you. It's like, really feels good to get there. It's been a journey. But it's interesting that black is so small and the white seems so big. The green is the biggest of them all. There's actually something interesting here. You know, all the colours, you look at the colours in that cube, and the one that is the biggest colour of all is green. But this is because the eye doesn't have an even distribution of colours, and it so happens that green is the one that we have the biggest range visually in. And so subjectively, green is the biggest. It's interesting putting it on a cube like this, you really see it. Red is smaller than green. Yellow is about the same size as green. Blue is actually bigger than red. Magenta, which is a fake colour, it's kind of curious, and it skews. Magenta is bigger in going into black, but magenta to blue, where is it? There was one there. Yeah, it's small going into blue and whatever. It's kind of interesting. I'm getting dizzy looking at this now. Let's bring it back down to there. My head is spinning. Here we go. Big like that. Yeah, it was a lot of effort. But what did I learn? What did I learn doing this? Yeah, I learned about geometry shaders and everything else. Yeah, it does. These things are not easy, you know. So my question, because when I started off with OpenGL, I found out that all of the old API was removed, which was really annoying because I wanted to just get on with it and start working. And instead I've spent the last couple of weeks but you know what? It's good on that point because I finally been doing some serious shader work, and that's good for me to learn that. Even in Unity, right? It's not something I've usually had that much interest in, but You know, as long as I could let go of what my main project was, and then go and work on this for a bit, and it was fun. But it all became down to the fact that they removed quads. And one thing I love to do with quads is to colour the 4 vertices and have it interpolate. And so now I was like, how do you do that? Well, it's not too difficult. You just have to invent a mesh format. You have to duplicate your colours and whatever is necessary to fit around a shader where you take in the vertex shader, you take it's been a bit simplified now because there's some of the earlier ones. But yeah, what does it use now? Well, color. Yeah. So now I don't need this anymore. I just take a color, and yeah, it doesn't need this anymore. It doesn't need this anymore, but it does need this and this to feed. So the vertex shader feeds into the geometry shader here, the color and the UVs, and it has to output 4 colors and the UVs. And what it does is it takes the color from 4 vertices. So in order to do that, then you have to render your mesh using triangle adjacency. So that's where this comes in. Where was it? Here. This renders one triangle with 6 vertices, of which 2 are not used, 3 to render the triangle, 1 to reference the 4th vertice, the one that has to be blended to as well. And that renders one triangle, and this is the second triangle, so together this makes a quad, and there's 1, 2, 3, 4, 5, 6 quads. These are just sort of sorting out the algorithm. This could be done procedurally rather than with data, but for setting up, that's fine. So basically, the geometry shader is able to access these 6 vertices, but I only use 4 of them in here. These 3 are the actual triangle itself, and this is the the adjacent vertex. So I pass through the coordinates, the texture coordinates, and the position for the 3 vertices in question. The 4th vertex is used to set the color. Each vertex receives 4 colors. Well, in the fragment shader. This gets passed on to the fragment shader, is the fragment shader code, which doesn't use this anymore, but does use color 1, color 2, color 3, and color 4. Inside the shader, the fragment shader, it takes, that doesn't not used anymore, but no matter, it takes a mix of color 1 and color 2 according to the x position, the x coordinate, the UV. It mixes color 3 and color 4 according to the x coordinate, the UV. So it's blending between the 2 top ones and between the 2 bottom ones. And then this gives you a 2 blended colors, and then it blends between those for the y. So in this way, you have a 2-dimensional blend where the UV values go from 0 to 1 for one vertex to the other vertex, and 0 to 1 for up here, and then vertically 0 to 1, and you get the color that is the one that you want. And that is what's outputted to the from the fragment shader and becomes the color that you see on the screen, on the thing. So it's quite interesting because when it's rendering the triangle, it's basically a dynamic texture that it's doing. It's the 4th vertex is actually influencing the shading of the other 3. And in this way, you don't get any kind of artifact on how the triangle, how the quad is split, which is why you don't see any sign of the split here at all. And there are things I can do to optimize this now, and from what I've learned. I mean, this is like version 4, I think, 3, maybe version 3, because I did achieve this without the geometry shader, but it was a lot of data on the mesh to do that. But I can still improve it. In fact, what I can see to do probably next is it's a little inconvenient to have to specify these UVs. I can get the geometry shader to do it because it's the same pattern, except there is an inversion required when it's the second triangle of the 2 triangles. So the geometry shader will need some way of knowing whether it's part A or part B, triangle A or triangle B. But I think what I can do is use one of these. Now this is a bit cheeky because they're not supposed to be used this way, but who cares? Basically the adjacency information, this thing was constructed with the idea of being able to do tessellation. But what's beautiful about it is that you can abuse these things, because it may be that the people who designed the API were only thinking tessellation, but I'm thinking it's a way to dynamically get any information into the geometry shader. So I can make this 0 or 1. So it could be done like this. 0, 1. It's an index, it's an int. So if I do it like this, then the geometry shader can look at that, and if it's a 0, it can generate the UVs itself, and then there's no need. It could use this one for 0 and this one for 1. It could generate it itself, and then the mesh doesn't even need UVs anymore. Which is good, because the UVs serve no purpose other than, you know, a requirement for the fragment shader. And that will reduce the size of the data that's required even more. Another thing that could be done is, as I was saying, is I could actually put the whole thing in the geometry shader and just pass it a point and tell it, I want the cube to be this size. And well, you need to do that. You just put that size in the matrix. No need to be a size. It's a point with a matrix, and the geometry shader just creates 12 triangles and just says, do you want these are the 8 colors you want? Well, yes, certainly, and dynamically creates the cube. This is actually really quite nice, a lot of fun. And I'm now thinking, what can I do? What kind of things could I do with this? Yeah, I like. Put this back. So where does that leave things? Having broken the back of this particular problem, I've also now got the start of an engine. All of this is being sort of requested from my main here through an API which wraps the really hideous API of OpenGL as it is now. It is pretty hideous. I mean, I understand that you want this kind of flexibility and all the rest of it and so on. And there's probably a lot of performance reasons for the reason it's been set, but it doesn't change the fact it's actually a really ugly API. And if you want to sort of use OpenGL effectively, you will need to wrap it in some way. So this is my wrapper on it. The thing I don't like is that I've got things like light meshes triangle adjacency, which feels like a leaky abstraction, you know, it feels like I've gone. But the way around that is that you create the API with layers. So there's one form of the API which is kind of less flexible but easier to use because it's just doing the normal stuff. And then there's a secondary API that you can use for which things like this would belong. And then you put them in there. But where I was supposed to be heading, and where I'll be getting back to now, is I have Nugget integrated together with this, or at least my Nugget, my C Nugget implementation, where Nugget is an architectural framework. And I can receive data on a socket. So what I'll be doing is making it a network renderer. And what I really want to be able to do is to drive the whole of OpenGL, maybe not in one go, but eventually to drive the whole of OpenGL over the network so that I can have a very simple standalone program written in any language that can connect up to a socket and be able to do whatever I like. And now that I've started to do shader work and get down to the shader level, I think it would be really good. There are, of course, things like Shader Toy and GLSL Sandbox, but there doesn't exist that I could find an online shader tool, whatever, that does the full pipeline. So most of them, Shader Toy and GLSL Sandbox, only do the fragment shader. There is Shader Frog that looks quite nice, but if you want to upload your own model, you'll have to pay for it. $10 a month. It's quite expensive for something that I would in the end only use occasionally. So, and now I don't really need to use it because I've got my own thing. But even Shader Frog, it does. What's nice is it's got a vertex shader and a fragment shader, so that's quite nice. But it doesn't have a geometry shader. There isn't one out there that does geometry shaders. I think I have in mind as kind of as a good project for testing Nugget out and for helping with a problem. This would be a great project. The problem is the one of who, now if you want to do graphics programming, you see OpenGL was lovely because it was a simple API and you could get started with it really quickly and you could learn or prototype really fast in it, and it was nice and it would always work. And now they've gone and removed all of that stuff, and if you've been following me, you've seen how long it's taken to just get to me, because it's at the same level of difficulty as in the old days trying to figure out how to blit, you know, how to use the hardware of the Amiga to sort of blit sprites up onto the screen. And it's the same kind of level of difficulty where you're accessing the hardware directly. And there's like, this API is at that level. It is practically accessing hardware. I mean, it feels that way. And you're not really accessing hardware because there are many layers, or at least one, and you don't get to hit the hardware. But it's of the same feel and the same principle in the end. I'm not really seeing much difference. Got lots of state. You've got to arrange your data in a very specific way. You've got state in that you need to make sure that you are in a particular mode when you add the data to a buffer, and it's pretty low level. So the problem there is that if somebody wants to learn graphics programming, then you hit with this wall, or you go and use stuff from other places. Like, for example, you follow the tutorials and they say go get GLM, the GL maths library that somebody made, but it's in C++, and I think it's probably huge. and I don't think it's as small as mine. And then it's, oh, you've got to get, which version do you need? And it just, so what I'm thinking here is to make a, I would actually quite like to recreate the original OpenGL API by making a layer over the modern OpenGL. I should have called it something else, but the modern OpenGL API. So that then it's important because it means that people who are learning about graphics can make use of all those tutorials out there that were based on the decades of material. And what about old programs that are out there, old demos, old games? It's like, I think it's kind of important. So I might do something like that for the spirit of making it fun to do computer graphics, because I can tell you that it's not really that much fun. I mean, maybe I would get a kick out of it, but then I've been programming for a long time. But I imagine that for a lot of people, they say, I want to make a video game, OpenGL. I mean, honestly, the original one had the teapot, you know. You could at least go and say, I want to render the teapot. And you would have some code about this long, and you'd have a spinning teapot on the screen. And you'd feel you'd accomplished something, and you will accomplish something. That's not, it was like what Mike was saying about, you know, spending 2 weeks to get a triangle. I wanted it on the 3DS. It takes a special kind of perseverance. Shame if it puts people off. I don't know. Anyway, I think I'm pretty tired, and I think this is a good place to leave it. So I'm going to take off. Thanks for watching. If there's anybody there other than just Mike. I don't know what happened to Gavin. Gavin showed up earlier and said hi. I don't know if he's still here. Probably not. Thanks for watching. I'll be back soon. Cheers.